So in this video, we're going to be looking at graphing hyperbolas and writing equations for hyperbolas. So you'll notice that there are two types of hyperbolas. You have a horizontal hyperbola that opens on the x-axis, and you'll find this to be true when the x variable shows up as positive. So notice that the x comes first. And then you've got vertical hyperbolas that open up and down, and you'll find this to be true when the y value shows up first. And the other thing that you'll notice about hyperbolas is that the equation looks somewhat similar to the way the equation looks like for an ellipse, but it's got subtract. So it's x squared minus y squared or y squared minus x squared. And the hyperbola, instead of coming around like an ellipse, is opening away from each other. So you've got these values underneath here, A and B. These values are dictating how wide this box is right here. So this distance from the center out to the vertex, this distance is A. So we go out A spaces in each direction, right? And then this distance right here, the distance from the center up to the top of the box is B, and then again down, this is B. So the box is like 2A by 2B. And then you'll notice that the asymptotes are the diagonals of the box. And then the hyperbola is drawn from the vertices, right, here and here, out toward the asymptotes on each side, right? So same thing if the box opens up vertically, we're still going up A spaces to the vertex, right? So up A spaces to the vertex and down A spaces to the vertex on the bottom, right? And then as we're drawing our box, then it's going to go B spaces out. So the box size is 2A by 2B. The diagonals of the box become the asymptotes. The vertices are up and down instead of right and left on what we call the major axis. And then when we draw the hyperbola, we draw it from the vertex out, getting closer and closer to those asymptotes, those red dashed lines. Those are the asymptotes. And they're not part of the graph, they're just there to help us draw the shape of the branches of the hyperbola. So you've got two different orientations, right? You've got a horizontal orientation. That horizontal orientation, again, is going to happen when the x squared is positive and comes first, is written first. And then we've got a vertical orientation when the y squared is written first. Just like an ellipse, the center is going to occur at HK. And then we're going to travel plus or minus A spaces, right, horizontally to get to the vertices. And then again, just like the ellipse, we're going to travel plus or minus C spaces, right? That's the focal length to get to the foci. The important thing to notice here is that the foci are always going to occur on the same axes as the vertices. So notice that this line right here that contains the vertices, that's the same line that contains the center and the foci. So this guy right here, right, that's the major axis. And then the opposite direction would be the minor axis or the conjugate axis. Okay, so we'll write major or transverse. For my vertical ellipse, on my vertical hyperbola, the transverse axis runs this way. So that's the transverse or major axis. And you notice that the center, the vertices, and the foci all lie on this vertical line, the transverse axis. Okay, and then again, the asymptotes come from making the box. And then one thing that is really different from the ellipse is how we find the focal length. So you're basically using the Pythagorean theorem, a squared plus b squared equals c squared, and solving for c to find the focal length. So these are the major components of the hyperbola, both vertical and horizontal. And instead of memorizing all of these rules for how to find each one of these, most of the time you can find them just from graphing, and I'll demonstrate that. Okay, so the first problem we're going to look at is graph the hyperbola given by the equation. So one of the things that you'll notice in this equation, this is like x minus 0 squared and y minus 0 squared. So we know that this hyperbola is going to be centered at the origin. We also notice that this value right here, this is a squared and this is b squared. So that tells us that a is going to be 7 and b is going to be 9. Right? So again, we notice that the center is at 0, 0. Right? And if this value right here is 7, right, then when I graph it, I'm going to be going plus 7 spaces and minus 7 spaces from the origin to find the vertices, right? And because this space right here is b is 9, that means that when I form my box, right, I will be going up 9 spaces and over 7 spaces to find my asymptotes. So what that means is that when I draw my asymptotes, the rise over the run is going to be 9 over 7. And that's where they're getting these equations from right here for the asymptotes, plus or minus 9 over 7. They're getting them from the values of a and b that I have in my problem, from these values right here. Okay, so that's where you're going to find the values for the asymptotes. Okay, so now that I have a is 7 and b is 9, I need to find the focal length, right? So remember, the equation for the focal length is a squared plus b squared equals c squared. So I'm going to get 49 plus 81 equals c squared and solve for c, and I get 11.4, right? So again, I've got 11.4 for my focal length. If the vertex or the center of this hyperbola, if the center of this hyperbola is at 0, 0, right, and we already know that the vertices are going to be at plus 7, minus 7, and the focal length is 11.4, then my foci are going to be out here at 11.40 and negative 11.40. When I graph my hyperbola, right, it's going to end up looking something like this. Right? There's the center. Oops, my vertices are at the wrong spot. Off the vertices, wrapping around the foci. Right? How did I know it opened right and left? Because this is going to be a horizontal hyperbola because the x squared comes first. Okay, so here's what my final graph looks like, and this is the way you're going to do it. You're going to start by graphing the center, right? So the first thing you're going to do is you're going to graph the center. There it is, right there, 0, 0. There's the center. Now we're going to draw the box. So remember how we were going to draw the box. Underneath x was 7 squared. So we would go 7 spaces out this way and 7 spaces out this way, right? And then underneath the y term, we had 9, right? Underneath the y term, we had 9 squared. So that means that I'm going to go 9 spaces up and 9 spaces down. Now that's going to make a little box, right? And when you draw this box, you'll find that the asymptotes will go right through the corners of the box. So notice that the asymptotes go right through the corners of the box, right? And that because this is 9 up here, the slope of this asymptote is rise over run. The slope of this is 9 over 7. So to actually graph the hyperbola, we put the asymptotes in. Those are the red dashed lines. And then we draw the branches of the hyperbola. So starting at the vertex right here, going out and along the branches. Out and then getting closer and closer to the branches. So again, starting at the vertex here, and then out toward the branches, out toward the branches. And you can plot a couple of points just to get the exact shape. All right, so let's take a look at this one. Graph the hyperbola given by the following equation. First thing we're going to want to do is we're going to want to find the center. So remember, there's your H and there's your K right there, right? H and K. And that means that the center of this guy is going to be at 2, -4. The other thing that I notice is that on this graph, I'm going to be going, this is 2 squared, right? So when I make my box, my A value is going to be 2, right? And my B value is going to be 3. Because this is 3 squared. Okay. So that means I'm going to be going right up and down 2 spaces to make my box. All right. Up and down 2 spaces. And then the width of the box is going to be 3 by 3, right? So now we know that A and B values, and we can plug them into the equation that solves for the focal length. Okay. So we're going to get 4 plus 9 equals C squared. And we get C equals the square root of 13, or about 3.6. So when you're graphing, you'll just have to estimate where that is. Okay, so here's a summary for this. Right, again, the center, H and K, right, come from here. There's my H, and there's my K. And then to find the vertices, from the center, we're going to add plus and minus 2 up and down to the Y value, right? So plus and minus 2 from -4 gets us -2 and -6. And then for our value here for X, right, we're going to go plus and minus 3 spaces right and left. So that just gets us the size of the box, right? So you'll notice like the 2 and the 3 that are here, that's the size of the box. That's the rise and the run. Right? This is the run and this is the rise. Ultimately, that's what makes the equation for the asymptotes have a slope of plus or minus 2/3. So where does the 4 and the 2 come from in this equation? That 4 and that 2 come from here, right? The coordinates of the center. So we plugged a 2 in here for X and a 4 in here for Y, and that gave us the equation of the asymptotes. Okay, so quick summary of how we graphed, right? We started by plotting the center. So the center was at 2, -4. So we always want to graph the center first, right? So we had 2, -4. And then underneath the Y value, we had a 4. So that was 2 squared, right? So we went 2 spaces up and 2 spaces down. And underneath our X value, we had a 9, so that's 3 squared. So we went 3 spaces out for X on each side, and that created the box. Once you have your box drawn, you can put in your asymptotes. Okay, and then the last thing we're going to do is we're going to draw the branches of the hyperbola. Right, and again, we draw those branches by starting with our pencil on the vertex and then going out, getting closer and closer to the asymptotes as we go on each side. So pencil on the vertex right here, and then going out, getting closer and closer to the asymptotes as we go.